Good morning, students. So today we are going to start our last topic of P block elements, and in this topic we are going to discuss about group 18 elements, which are also known as noble gases. We will discuss about the different elements present in this group, their physical and chemical properties, and then compounds formed by these group elements and their structures. Okay, so let us start. First of all, group 18 elements are helium, neon, argon, krypton, xenon and radon. Okay, and they are also known as noble gases. If we talk about their general electronic configuration, then it is Ns2Np6. In case of helium, it is not there because it is the smallest one and there are only 2 electrons, so it has the electronic configuration of 1s2. Okay, now why do we call these noble gases? They are so called because they show very low chemical reactivity. They are not at all reactive, so they are called noble gases. Okay, now how they occur in nature? All the noble gases except radon occur in the atmosphere. So radon is not found in atmosphere, but all the other gases are found in atmosphere. The atmospheric abundance in dry air is near about 1% by volume, of which argon is the major constituent. So means if we talk about all the noble gases, then near about 1% they are present in air, and in that 1% it is the combination of all. Major part is of the argon. Helium and sometimes neon, they are found in minerals of radioactive origin, such like pitch blende, monazite, cleveite. These are the names of ores. Okay, so helium and neon, they exist in these ores. Okay, main commercial source of helium is natural gas. So helium is found in a natural gas. Okay, xenon and radon, they are the rarest elements of the group. So minimum found elements are xenon and radon. If you want to prepare radon, then it is obtained by the decay of radium. When radium decays, okay, when radium undergoes decay, then it forms helium nucleus and radon. Okay, so radon is not found in atmosphere. This you can remember. Now electronic configuration. All noble gases have general electronic configuration of Ns2Np6 except for the helium, because there are only 2 electrons. Many of the properties of noble gases, including their inactive nature, are ascribed to their closed shell structures. Means why they are inactive or why they are noble in their behavior? Because they are having fully filled electronic configuration, or we can say they are having closed shell structure. Just like these are the elements, their electronic configurations, if we see, then it is 1s2 for helium, then it is 2s2 2p6, 3s2 3p6, 4s2 4p6, 5s2 5p6, 6s2 6p6. So this is the most stable form of electronic configuration for these elements. Okay, now if we talk about periodic properties, then ionization enthalpy. Okay, first of all discuss ionization enthalpy. Due to stable electronic configuration, these gases exhibit very high ionization enthalpy. Now see, they are having most stable form of configuration. So if we want to remove one electron, then we have to give a lot of energy. So it means ionization enthalpy value will be very high. Okay, and as we will move down the group, then its value will decrease because there will be increase in size. Okay, now similarly atomic radius, this is going to increase from top to bottom with the increase in atomic number. Okay, reason is because there is increase in main energy level. Similarly, electronic enthalpy, since they have stable electronic configuration and they have no tendency to accept the electron, so they have very large positive value of electronic enthalpy. Now positive value means that we have to give energy, then only we can add some electron in these gases. because they do not want to accept any electron because of their stability. Okay. Now, what are the properties of group 18 elements? All the noble gases are monoatomic. Okay, they are colorless, odorless, and tasteless gases. They are springly soluble in water, means they can be dissolved to little amount, little excess in the water. They have very low melting and boiling points because the only type of interatomic interaction in these elements is weak dispersion forces. Okay, since there are very weak dispersion forces, so they are having low melting and boiling points. Okay, type of interactions are very weak because of their inert nature. Okay. Helium has the lowest boiling point of any known substance. It has an unusual property of diffusing through most commonly used laboratory materials such as rubber, glass, or plastic. So it can diffuse through those substances which we are using in laboratory. It has lowest boiling point. Okay, so this is its rare property which we must know. It is having its boiling point as 4.2 Kelvin, which is very low. Okay, so helium has minimum boiling point, you can remember like that, 4.2 Kelvin, not Celsius. Okay, now in general noble gases are least reactive. Their inertness to chemical activity is because of the following reasons. First, noble gases except helium have completely filled ns2np6 electronic configuration in their valence shell, which we say it is complete octet. Okay, they have high ionization enthalpy and more positive electron gain enthalpy. Okay, the reactivity of noble gases has been investigated occasionally ever since their discovery, but all attempts to force them to react to form a compound were unsuccessful for quite a few years. So means when these gases were found, then efforts were there to form the compound by the use of these gases. But what happened, for few years there was no success in this field. Okay, now how this story begins and how we were able to find some compounds of noble gases, this is what we are going to study now. Okay, one scientist named Neil Bartlett, he was in the University of British Columbia. He observed the reaction of a noble gas. Firstly, he prepared a red compound which is formulated as O2PtF6 negative. Okay, helium, not helium, he then realized that the first ionization enthalpy of molecular oxygen was almost same as that of xenon. So xenon and oxygen, they were having first I even value. I even means ionization enthalpy value, that was almost same. So what he thought, that xenons should also combine. If oxygen can combine, then xenon should also combine. So he made efforts to prepare same type of compound with xenon. Okay, see this compound he found. Okay, then he thought that in place of oxygen there may be presence of xenon because they are having first ionization enthalpy value nearly same. So he was successful in preparing another red colored compound, and that was Xe positive PtF6 negative. Okay, so he mixed platinum hexafluoride with xenon and he found this compound. Okay, so the compounds of what we can say, that who made first of all the compound of inert gases or noble gases, it was Neil Bartlett. And what was the compound formed? XePtF6. You can write like this also, Xe, and then within bracket you can write PtF6. Okay, this type of compounds are called coordination compounds. Okay, now this is the compound of xenon. Now compounds of krypton are fewer. Krypton can also form compound, but they are very few. Just like one compound is known, krypton, KrF2. Compounds of radon have not been isolated but only identified. by radio tracer techniques. Now see, they cannot be isolated that this is the compound, but they can be traced with the help of some techniques that it may be present there. Okay, so argon, neon, helium, they haven't formed any compound till now. So in overall, what we can say that xenon can only form compounds out of all the noble gases. Okay. Now with which elements it forms compounds? It forms compounds with fluorine as well as with oxygen. Okay. Now what should be the reasons, what proposed reasons we can say? We will say that xenon has maximum size in the noble gases. Okay. And then because of that it can ionize easily. Okay. And so it can combine with most electronegative elements of the periodic table, and most electronegative elements of the periodic table are fluorine and oxygen. So there is possibility of formation of compounds by the combination of xenon and fluorine and oxygen. Okay, so now let us discuss about xenon fluorine compounds. So xenon and fluorine, when they are mixed in different ratios at different conditions of temperature and pressure, then what happens? They form difluorides, tetrafluorides and hexafluorides. Okay, now there are few more methods to prepare these compounds, just like XeF6 if you want to prepare, then by the combination of O2F2, dioxygen fluoride, and XeF4 we can make XeF6. Similarly, this okay, now see these fluorides XeF2, XeF4, XeF6, how they are? They are colorless crystalline solids and they sublimate at 298 Kelvin. 298 Kelvin is room temperature, so this undergoes sublimation at room temperature. Okay, they are powerful fluorinating agents. They are readily hydrolyzed even by traces of water. When very minute amount of water is present, then even then they will undergo hydrolysis. Okay, for example, if XeF2 it undergoes hydrolysis, then it will give xenon, hydrofluoric acid and oxygen. Okay, so here what we discussed that xenon forms a few compounds by the combination with fluorine. Okay, similarly xenon can form compounds by a reaction with oxygen. Okay, now see, if we perform hydrolysis process of XeF4 or XeF6, then there is formation of XeO3. Xenon trioxide is formed. Okay, now if we do partial hydrolysis means when amount of water is less. Okay, then what happens? There is formation of oxyfluorides like XeOF4 or XeO2F2. Okay, so this type of compounds are also formed. Now what about XeO3? XeO3 is a colorless explosive solid and it has pyramidal molecular structure, whereas XeOF4 it is a colorless volatile liquid and has square pyramidal structure. Okay, now let us discuss about the structures of xenon compounds. Now see, if we talk about XeF2, then Xe has 8 electrons. Out of those 8, 6 electrons are in the 3 corners of the triangle and 2 are one above the triangle, one below the triangle. Similarly, for XeF4, 4 fluorine atoms are at the 4 corners of the square. One is above the square and one is below the square, and this geometry is called square planar geometry. Okay, similarly for XeF6, it is just like octahedral shape, but the thing is that there is presence of one lone pair with xenon. Because of that lone pair there is repulsive force, and so the geometry is a little bit distorted. So what we say, it is distorted octahedral geometry. When we talk about XeOF2, then 4 fluorine atoms are at the ends of the squares lying on the same plane. One oxygen is bonded with double bond lying above the plane, and one lone pair is below the plane. So this is square pyramidal geometry. Now if we talk about xenon trioxide, then xenon forms double bonds with all the 3 oxygen atoms, and it is left out with one lone pair. So its geometry becomes pyramidal, just like geometry of ammonia. Okay. Now where do we use inert gases? These are having use in so many places. Just like helium is a non-inflammable and light gas, hence it is used in filling balloons. Okay, so for meteorological observations, those hot air balloons we use, or if some other type of balloons are to be used, then helium gas is used. Okay, because it is very light gas, so it moves upward. Okay, it is also used in a gas cooled nuclear reactor. So in nuclear reactor also it is used. Liquid helium, this is used as cryogenic agent for carrying out various experiments at low temperatures. So if some experiment is to be done at low temperature, then it is used, helium is used. Okay, it is used to produce and sustain powerful superconducting magnets, which form an essential form of modern NMR spectrometer and magnetic resonance imaging system for clinical diagnosis. So what do we mean? We want to say that there is a process called MRI. Okay, so in MRI also there is use of this helium. Okay, so these things are used. Now it is used as a diluent for oxygen in modern diving apparatus because of its very low solubility in blood. So what happens, helium gas has very less solubility in blood, so it is mixed in that mixture which is used for breathing during sea diving. Okay, now neon is used in discharge tubes and fluorescent bulbs for advertisement display purposes. Okay, now see, you might have seen advertisement boards where so many colorful lights are seen and something is written with the use of those lights. So there, what those tubes are, what those lines are, those are discharge tubes and they contain neon gas. Okay, neon bulbs are also used in botanical gardens and in greenhouse. So in greenhouse and botanical gardens, neon bulbs are used. Argon is used mainly to provide an inert atmosphere in high temperature metallurgical processes, just like arc welding of metals or alloys. So argon is used where we need inert atmosphere, just like during welding there is formation of sparks, so those sparks should not cause fire. So just to prevent such things, there is need of inert atmosphere. So what is done, such atmosphere is provided by argon. Okay, it is also used in the laboratory for handling substances that are air sensitive. So air sensitive substances, they are handled with the use of argon. Okay, what do we mean by this? We just mean to say that these things are kept in argon atmosphere so that air does not attack those things and air does not react with those things. Those substances are made secure by doing this. Okay, there is no significant use of xenon and krypton. They are used in light bulbs designed for special purposes. Okay, so these were the uses of this noble gases. Now whatever we have discussed, on the basis of that you have to solve these home assignments. Okay, thank you.